Hey there. In this video, we're going to look at a couple examples of a compound inequality and an absolute value inequality. One of the things to remember is whenever an inequality is linear, right, there's no x squared, there's no, it's not a rational function, we can just use our regular algebra manipulation to isolate the x. In this case, it's a compound inequality with kind of this expression in the middle is between negative a half and 1/4, so we just have to make sure we manipulate all three parts. I want to clear the fraction. I can multiply it by 20 to clear this fraction here. If I multiply the whole expression by 20, I'm going to get negative 10 is less than or equal to, that'll be what, 4 times 4 minus 3x? And that would give me 5. Alright, so now I've got rid of those fractions. That's kind of nice. I could distribute in the middle there. Negative 10 less than or equal to 16 minus 12x less than or equal to 5. And again, just kind of isolate the x now. So subtract 16 everywhere. Negative 26 less than or equal to negative 12x less than or equal to negative 11. And now we can divide everywhere by 12. Negative 12. Ooh, I divided by a negative. Gotta flip the sign, right? So I'm gonna get what? Positive 13/6. Cut those both in half. Switch the sign. Greater than or equal to. X greater than or equal to positive 11 over 12. Right, that kind of think, just do a check in your head, make sure numerically kind of makes sense still. This is a number smaller than 1, this is a number bigger than 2, so we're okay with this kind of order. And so that's my inequality solution. Some people prefer to rewrite it going smallest to biggest. Less than or equal to x, less than or equal to 13/6. Both are mathematically correct. We could also put this on a number line here. 11 twelfths. That's not very neat. 13/6. And I know that this inequality is saying it's inclusive, so we're going to fill in my circles. And it's an and problem. The solutions are between those two numbers. So shade in between. I could write a interval notation for this. And there we go. Next example. All right, here we got an absolute value inequality example. Quick reminder that if you have absolute value is less than some value, that's saying distance is less than. And if the distance is less, that means we're going to be shading in between, right? Because the distance is smaller than that value a. Here, if the absolute value is greater than a, like the second example on the bottom, my distance needs to be more than the value a, so I get a shade to the outside. And so when we solve these, we're looking for one of those two. This is going to be less than 15. My distance is less than 15. When we solved absolute value equations, there's a couple different ways you're taught, but we would usually say inside is equal to this number, and then the opposite of the inside is equal to the this number, right? And so we can do the same thing here. I can say 4x plus 5 is less than 15, and I can say the opposite of 4x plus 5 is less than 15. And then I need to solve both of those algebraically. This is going to give me x is less than 10/4, so 5/2. Here I got to divide by that negative first, gives me 4x plus 5 is greater than negative 15. And then that's what, 4x greater than negative 20. So x is greater than negative 5. And then when I combine these together, again, I know it should give me something like that. And that's what we'll see. We'll see negative 5 is less than x is less than 5 halves. And there's my solution. Same as last problem, we could number line that, we could interval notation it. And there we go. Thanks for watching.